Hey, we're back here again and we're going through the AV manual. This is number 38, Integration and the Natural Log. That's what we're dealing with. We dealt with differentiation before. Now we're dealing with the natural log with integration. So think that instead of this. Let's get started. First, the general idea is that if the derivative natural log of u is equal to u prime over u, then we're going to say that the integral of u prime over u is equal to the natural log of u. That's the general idea. Notice that this has absolute value in here. We got to be careful of that because you can't take the natural log of a negative. So let's work our way through this, starting with the first one. If I were to look at this and I were to ask myself, u would equal what piece? Well, the bottom would just be x, or actually even simpler than that. Let's go even simpler than that. If I were to change this so that it looks more like the first example here on the left, that would be, I could take that 4 on the outside. I would just have 1 over x dx. That 4 is just going to remain a constant. Then the integral of 1 over x dx is natural log of the absolute value of x. And of course we have plus c. For the second one here, when I look at it, I see 5x minus 2. And I would assume that u is going to equal that 5x minus 2 piece. Then I need to figure out what u primed is, or du, for my substitution. Du would just be 5 dx. I notice that I need a 5 up here, but it's not there. So I'm going to multiply by 5 and divide by 5 on the outside just to balance. Because what I'm really doing is I'm multiplying and dividing by 5 at the same time. So nothing really happened. It's just 5 over 5, or multiplying by 1. That winds up giving me 5 over 5x minus 2. I have a 1/5 on the outside in the dx. If I were to simplify this in terms of u and du, it'd be 1/5 times the integral du over u. Well, that's pretty simple, or 1 over u du. That's just going to equal natural log, we got the 1/5 on the outside, natural log of the absolute value of u plus c, which is really equal to 1/5 times natural log the absolute value of 5x minus 2 plus c. For this next one, we got a little bit of a combination going on. This 4 doesn't really help us out unless it has something to do with the derivative in the denominator. Well, let's look at the derivative in the denominator. If u equals 3 minus 6x, then du is equal to negative 6 dx. That 4 and that negative 6, those aren't the same thing. So let's see what we can do to balance some things. I'm going to pull the 4 outside. So it's going to be 4 times the integral. I'm going to have this dx. On the bottom I have 3 minus 6x. I need this to be a negative 6. So I'm going to multiply by negative 6 up top, but also divide by negative 6 out here. Again, balance. Do the same thing, but inverse operations on top and bottom, multiply and divide. And then we have what we need. We got a du on top and a u on bottom. So it's really negative 2/3 if I'm to reduce this fraction on the outside. Du over u, which is negative 2/3 times natural log of the absolute value of u plus c. Keep going and substitute u back in. It's negative 2/3 times natural log the absolute value of 3 minus 6x plus c. New color, red. Now here, just try to follow your instincts. I realize that it's slightly more challenging than the other ones. These other two are linear functions, slightly simpler derivatives. But let's see what we have and see what we need to get in order to make it look like du over u. I would assume that u is going to be this denominator. U equals x squared minus 4. Then du is equal to 2x dx. This 7 doesn't really help me then, so I'm going to pull that out. I'll have 7 on the outside. I have the dx already in here. I have the x squared minus 4. I need a 2. Oh, and I have the x as well. Pardon me, that x is there as well. I need a 2, so I'm going to multiply by 2 and divide by 2 at the same time. Now I have my du, I have my u, and a constant outside. It's going to become 7 halves times the integral of du over u, which really equals 7 halves times the natural log of the absolute value of u. If I simplify, plus c, of course. If I were to simplify that just a little bit further, it'd be 7 halves. Natural log, substitute back the u. X squared minus 4 plus c. Well, it's our constant of integration because these are indefinite integrals, not definite. Let's keep moving. In 5 through 8 here, they're telling us do the u substitution. Now in the first ones you didn't necessarily have to. You could have done a little bit of algebra on your own just to figure it out, but here we're going to formally do a u substitution. Excuse me. For the first one, u equals, what would you assume? When I look at it, I would probably assume that 16 minus x squared is going to be my u. Then my du is equal to negative 2x dx. So when I look at this up here, that means I need a negative 2 here, and I'll multiply by a negative 1/2 outside. That'll balance it back to 1. The value won't change. That gives me negative 1/2 times the integral. On top I do have a du, but on bottom it's not exactly u. Instead it's square root of u. If I were to rewrite that as a power, it would be the integral of u to the negative 1/2 du. This does not follow a natural log template, or formula, or pattern. So not always are we going to do a u substitution for a natural log function. And this is one of those cases where it's not going to happen. U to the negative 1/2, I'm going to follow general power rule. So it's going to be negative 1/2 times u to the 1/2 over 1/2 plus c. Now this 1/2 down here is really times 2 over 1. And the denominator here and the numerator here for the 2's are going to reduce down to 1. That gives me negative u to the 1/2 plus c. I'm going to go ahead and substitute u back in. In this case it's 16 minus x squared. One way that you might see this written is negative. Instead of 1/2 power, you might see it written as a radical. Not necessary to do that, but if you have a multiple choice exam or some teacher that just says you have to keep going as long as you can, I guess you could do this too. New color. Here, I notice that I'm not going to have a u substitution because on the bottom it's really 1 over u to the 1/3 power, which is going to be u to the negative 1/3 power. So we're going to have a very similar action as what we had happening in the first one. So let's go ahead and identify our u and du. U equals that inside layer, which in this case is 2x minus 1. Du, then, is going to be just 2 dx. I need a 2 here. So I'm balance it with a 1/2 on the outside. So when I translate this, it's really 1/2 times the integral of du over u to the 1/3. Like I was just saying, u to the 1/3 is actually u to the negative 1/3. So it's 1/2 times the integral of u to the negative 1/3 Simple power rule, add 1 and divide by that number as well. We'll have 1/2 on the outside. U to the 2/3. Now when I divide by 2/3, that's really multiplied by the reciprocal, 3/2. Now when I put all these pieces together, it's going to be 3/4 is our constant, times U to the 2/3, plus C, of course. I forgot to put plus C on that part. Plus C. The U is actually 2x minus 1. And there we go. On to number 7. Ooh, I thought it changed color. Let's get a purple one. Now this one isn't exactly obvious, but it helps if you maybe rewrite the denominator and numerator as separate pieces. So I'm going to rewrite the numerator and the denominator separate. Now when you see this, if I look at this first term and the dx, that makes the derivative of the inside layer of natural log of x. That tells me that I can use that inside layer as a u substitution. U equals natural log of x, du equals 1/x times dx. So there's my du. These two pieces right here are du. And this inside piece here is u. So when I translate it now, it's going to be u to the 4th times du. Back to simple power rule. The antiderivative of u to the 4th is just u to the 5th over 5 plus c. And u happens to be natural log of x. So it's natural log of x all raised to the 5th power over 5 plus c. Now for number 8, I like to use a specific strategy when I have multiple numerators and one denominator. And that strategy is just separate it into separate integrals. Take it apart. The first one is going to be numerator x squared, denominator x, dx, of course. Then for the second one, I'm going to go ahead and factor out the 2, and then the numerator, I'm going to factor out this constant negative 2, but the numerator and denominator is x over x. Then the last one is plus, we got a 1 times 1 over x. Don't forget the dx here and here. Now each of these integrals is going to have a separate approach. That's why we like to separate it into different pieces, because each piece can be done easily but differently. The first one is really the integral of x dx. The second one is just the integral of 1 dx. And then the last one is a logarithmic, or natural log, pardon me, 1 over x dx. So when I try to integrate x dx, that's going to become x squared over 2. For the second one, the integral of 1 dx is just x, so it's minus 2x. The third one, the integral of 1 over x dx, is natural log of x, so it's plus natural log of the absolute value of x plus c. There we go. Pretty easy, especially when we separate it.